An integral is improper if one or both limits of integration are infinite, or the integrand is unbounded in the limits of integration. So in this case, the natural log of 0 is undefined. So we can use limits of definite integrals to evaluate these improper integrals. So for the first example, we replace infinity with a dummy variable that approaches infinity, and then the integral is written as follows. And then you evaluate this definite integral and then take the limit to obtain the result. Now we have both limits of the integral being infinite, we can evaluate this integral piecewise. And you can use the same method to introduce a dummy variable, evaluate the integral and then take the limit. And similar with this third integral, we can introduce a dummy variable. So this approaches 0 from the right hand side, where the natural log of x is defined. Then you can evaluate the definite integral and take the limit to get the result. And we'll cover several examples. Let's determine if this integral converges. So we know there's a discontinuity at x equals 0, so we need to evaluate this integral piecewise. So we evaluate from -1 to 0 from the left hand side, and then plus the integral from 0 from the right hand side to 1. And because these are improper integrals, because the integrand goes to infinity when we sub 0, so we use dummy variables. So in other words, we take the limit as a dummy variable goes to 0 and replace this limit of integration with the dummy variable. And we do the same for this integral. And now what you do is evaluate the integral, take the limit to determine if the integral converges, and post your answer in the comments. Let's determine if this integral converges. So what we have is an improper integral because we have a limit of integration that's infinity. So we replace that with a dummy variable and take the limit as a dummy variable goes to infinity. So effectively we're integrating from 2 to b, and our integrand is 1 on x squared. And now we can basically evaluate this integral, so we get -1 on x, evaluated from 2 to b, and we take the limit as b goes to infinity. So what we obtain is the limit as b goes to infinity of -1 on b minus a half. So when b goes to infinity, this term disappears, and therefore we obtain 1/2, and therefore the integral converges, because we obtained a finite value. Let's determine if this integral converges. So we have an improper integral because we have a limit of integration that's infinity, so we replace this with a dummy variable and take the limit as a dummy variable goes to infinity. And because we have a constant, we can take the constant outside. So what we have is 1 over 1 plus x squared evaluated over x. So this integral evaluates to an arctan, so we have 3 by the limit as b goes to infinity. And we have arctan of x evaluated from 0 to b. And therefore we have 3 by the limit as b goes to infinity of arctan b minus arctan 0. And arctan 0 is 0, and as b goes to infinity, arctan b approaches pi on 2. So what we get effectively is 3 pi on 2, and therefore the integral converges. Let's determine if this integral converges. So we have an improper integral because we have a limit of integration that's infinity. So we take the limit as a dummy variable goes to infinity and replace the limit of integration with that dummy variable. and we evaluate that integral and then take the limit. So using u substitution, you'd obtain the following result when you evaluate that integral. So we have the natural log of x minus 1 evaluated from 2 to b. And therefore we have the limit as b goes to infinity of the natural log of b minus 1 minus the natural log of 2 minus 1, which is 1. And the natural log of 1 is 0. And as b goes to infinity, this is going to go to infinity, and therefore the integral diverges. Let's determine if this integral converges. So if we plug in x equals minus 3, the integrand goes to infinity. So therefore this is an improper integral, and we thereby replace the limit of integration with a dummy variable. And we approach 3 from the right hand side. And think about why that is. So we evaluate the integral from b to 2, and we have 1 over root x plus 3. So you can use u substitution to evaluate this integral. So what we get is the limit as b approaches minus 3 from the right, and this evaluates at 2 root x plus 3, evaluated from b to 2. And what we get is the limit as b goes to minus 3 from the right hand side of 2 root 5 minus 2 square root b plus 3. And as b goes to minus 3, this term disappears, and what we obtain is 2 root 5. So therefore the integral converges. Let's determine if this integral converges. So if we substitute 0 into the natural log, you're going to get an infinite value. So therefore we can use a dummy variable and take the limit as b goes to 0 from the right hand side where the natural log is defined, and we integrate from b to 3 of x by the natural log of x with respect to x. And now if you evaluate this integral by parts, you're going to get the following result. So what we have is x squared on 2 by the natural log of x minus x squared on 4 evaluated from b to 3. And therefore we get the limit as b goes to 0, and 3 squared on 2 is 9 on 2 by the natural log of 3, and then minus 3 squared on 4, and minus b squared on 2 by the natural log of b, and then plus b squared on 4. Now as b goes to 0, this term disappears, and if you use L'Hopital's rule, this limit here is going to evaluate to 0. So verify this, and therefore the integral converges to 9 on 2 by the natural log of 3 minus 9 on 4.